Hello and welcome back. What are we going to do today? Well, it's the same thing we were doing earlier today, Pinky. Try and improve the bird model. So before we were using, convolutional neural network. And so right now, that's what I'm going to do is I'm going to come in here and start that old machine, grab some of the code from it, and copy it over to this new machine. You could be like, well, why do you have two different machines and you're copying the code? Why not just use the original machine? You know, I don't have a very good answer for you other than it was time to segregate this off into its own project. Most of the stuff is running under the business account, but I'd started this. Well, the billing, goes to the business account. I started this under my own personal account, and I don't know if you've ever noticed this. Sometimes you create cloud resources, and they just sit there. Like you make a bucket and you put some data on it, and it just sits there. And every month you're like, oh wow, I should really clean this up. I'm paying for this data that I probably don't need to be. But you're busy. You have a lot of things going on. So finally cleaned up that and moved all of the birder stuff to its own project. So that way you can always see just a data usage, billing usage for one project. So anyway, what's going on here? We're going to go into screen, Jupyter. And this one I don't have a token saved, I don't think. So I have to copy this over. So it's the B. Bada bing. Alright, where's our model? It's in TT, and I think B1K, because I was training on 1,000 birds. B1K. Feature writer. B1K training. And this one's going to look a little messy because I'm pretty sure I was mixing all these other TFRecords around. Let's make sure it was balanced. And this time we're not going to do that. Why aren't we going to do that, you ask? Because I have already mixed the TFRecords whenever we're creating them. Do you want to see? I'll show you in another video. Alright. Model 1. CNN Model 1. What are we going to put in here? Okay. So we have our spectrogram, which is 512 by 512. How many classes? 105 classes? 105 classes? How many features do we have? I wonder why I need that. Training groups, 143, I don't need that, don't need that. Layers, models, callbacks. I wonder what I'm using the callback for. We're going to remove that for now. And these are all TFRecords, so coming back out, it's going to look about the same as this. Oh, that's why I needed it in features. Because this is... I bet you're using features in a couple different places, and that's why I pulled it out. So a quick, easy way to sum a tuple. Can you multiply a tuple? Tuple. Math import prod. Interesting. Alright, where are we at? Over here. CNN model. So in features before, it's 512 by 512. Let's use this fun little from math import prod here. This is a product of the spectrogram size. Keep that as S. Okay. So we parse it. We come back here. We grab the spectrogram key. Label, cast that to an int32. Okay. We're reshaping that to that. And that's why I had that other number there. Okay. Now, what are we returning? We're returning 3 labels here. Because this is an inception model. Should we keep it that way? Let's keep it that way for now. Okay. What's going on now? What's going on now? We're going to make a data set. Let's see, from a train test key, but you know what? We don't have any other data sets, so we're just going to kind of cheat right here and say, where you at? Something like see, file names. See, it's expecting a string or a data set containing the file names. So there's a data set for that too. Where's it at? I think I might even have it right over here, right? Data set, file names. Glob. TF data, TFRecord data set. So like from list or list files. Check that out. The file pattern argument should be a small number of glob patterns. Instead of reglobbing every file name with those files may result in poor performance. Example, let's try this. How did they use it? Boom, 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 boom. Dataset map. That's about to be easier just to tired of waiting on this one. Check it out. From glob, hit import glob. Come over to here. Where are we at? I did have it right there, didn't I? List files. Since that's what we were trying to do, and it's a cleaner way to go forward, let's do it this way. /data /TFRecords /star.TFRecord. And this is where we'll put our repeat. Boom. So in other words, it's going to read from one file, then the next file, then the next file, and it's going to start at the beginning again. This data set equals that, and that. Okay. Try batch of 16 first. We have a map. Shuffle. I really feel the need to shuffle them because they're already shuffled. They are. They're shuffled very well. There we go. So that's our input. Model is equal to this. Number of filters, number of blocks. Oh yeah, that's how many times we're looping around through this, isn't it? All right. What's going on now? We're getting there. So let's just for now call number of filters 16, number of blocks. We'll keep that as 4 anyway. So what's going on here? We're doing a two-dimensional convolution with a 7-2, keeping the same padding, doing max pooling, batch normalization, doing it again, and then sending it into this. It's kind of weird. What if we start with something stupid simple? And that's going to be this right here. So we got 256 by 256. Right now, 512 by 512. So if we started that by, then we're talking spectrogram. Start in small pieces and move up. Sometimes it's nice to take a 2 and a 3, combine them. I mean, that's essentially what we're doing here, right? Like Inception grabs a 3 and a 1 and a 1, 5. Let's see, pulling 1, 3, 5. Concatenate them all, move them together, spit it back out. But again, I'm asking myself, like, what is the what's the primary objective at this point? It's a simple CNN. How simple of a CNN? If we're looking at an image that's 512 by 512, well, we're really talking a simple CNN. That would be, let's see, just start by 2. And max pulling 2 and 2. So at this point, what should we have? We should have 256 by 256. And if we do this again, we would have 128, 128. Do it again, 64, 64. Do it again, 32, 32. And do it one more time. 16, 16. Okay, so now we're going to flatten that. Get out of dropout. We could do things like that. Average pooling. No, I'm just going to make a big ass dense layer. Already flattened. No dropout. Well, okay. We could do a time distributed dense layer and then we could do another dense layer, couldn't we? Let's do that. That sounds more fun. Equals KL dense. How big of a dense layer? Let's just say 64 for fun. 2 of them? No, just one. Just one. Then we flatten it. Then we're going to add another one, but we're going to make this one a little bit bigger. Why is it bigger? Why would you make this one small and this one big? Because that's not really the case. This is actually going to be 64 times 16, right? Because every point in our time series is going to have this dense layer applied, because at this point it's still 3-dimensional. Here we move it down to 2-dimensional, one more dense unit on it. Let's throw a soft max in. All right, let's say M out. Let's see, this. No, and then there's our classes. Skip that. Inputs, outputs. It's just M out, M in. Compile. Sparse categorical cross entropy. Atom. And then that accuracy. Here's our checkpoint. Okay, my checkpoint was saving things. What does that model look like? It looks like it doesn't work. Cannot import name prod. I guess we don't need it anymore anyway. Why not? Didn't it say over here that that worked? Where did we see that at? From math, import prod. NP as a prod. Could use that. Weird. Okay, where are we at? Over here. Did our model compile? It did not yet. It is mad. Why are you mad, model? You're mad because prod is not defined. Didn't we already get past this? Or did I? I still used it right there, didn't I? Oh, that was glob I'm thinking of that we didn't use. Infilters is not defined. Infilters is defined right here. Right below where you're expecting it to be. Maybe look at that, look at that. We got a model with 48,000 trainable parameters. Okay. What happens if we just call fit on this, right? Is it called model? It is called model. Model.fit dataset. And there's like other things I need for this. It's like steps per batch. There it is. Fit batch size. Multi-processing steps per epoch. That's what we're looking for. Steps per epoch and epochs. So let's say epochs, however you say it. Then and then steps per epochs is equal to 1,000. And we're batching these by 16. Let's see if we have a 2-core box right now. If it got an expect keyword steps per epochs. Boom. Okay. ETA 5 hours on this. 5 hours. Should we add a GPU? I think we should add a GPU. Alright, let's make sure this notebook's saved. It's saved. Come over here to this box and say, actually, can I get it to shut down quicker if I go over here? Let's find out. So what we're going to do is we're going to shut this box down, and then we're going to go over to these instructions right here on how to use the GPU for Ubuntu 18.04, and that's why we installed Ubuntu 18.04, because of that's where GPU support is. I'm tired of waiting on that box to answer, so we're just going to go ahead and say, hey box, stop. Yes, please stop. Enjoy how it gives you a warning every time whenever you're stopping a box when you're starting it. Like, hey, this is going to cost money. Hey, are you sure you want to turn this off? Yes, that's why I pressed the power button. This is not the page I was looking for. They have a really nice page here. There's all these little, there we go, computer that. This is what I was looking for. Secure boot complicates this beyond scope. Okay. So when this box turns off, we're going to come back. It's off now. And let's see if it lets me add a GPU. succeeded. Yeah, I know. Okay, so you let me do it with that. N1 standard. What if I switch to an N2 powered by Cascade Lake? N2s have no GPUs. First generation. N2D, no GPU. But our N1s have GPUs. Two naval, use that, okay. So we're going to choose an N1 standard. Let's do a 4. It's a little bothersome that it's 4 and 15 and not 4 and 16. Does that make any sense to anybody? Alright, so we're going to start with this GPU. I think the K80 costs like $1 an hour, something like that. I'll be a little conservative with it. Oh, it's mad. Yeah, I don't care. No support on hostmate unless they are preemptible. What are you mad at? You don't support. Where's our on-host maintenance thing? Blah, 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 blah. Shielded VM, don't really care. Access controls, fine. Where is the on-host maintenance? You're going to be kind of gripey and not let me switch from one to the other, aren't you? Oh, that's interesting. So you have a specific... Will you let me do this, please? Please. No. Well, let me do that unless it's preemptible. So maybe we switch to N2 first, and then we can change that setting. Maybe. Sometimes it'd be really nice if there's a way that this console could edit the value for you and then let you know, like, hey, I had to change on host maintenance and what you're doing there because this doesn't support it, right? You can only do that with the E2 types, not the N1 types. Let's find out. Anyway, so we're switching this from E2 to N1. Let's pause here.